together from clips of film made under a research program in computer. The images are arranged to illustrate this talk, which will be an attempt to suggest some of the formal problems that hold my interest regarding design in motion. This is the IBM 2250 graphic display console that generates the images in motion which I have been exploring. Dr. Jack Citron of IBM, who developed the computer program for this project, is demonstrating the way we select numerical variables that determine a particular graphic pattern. The program is based upon a single polar coordinate equation having about 20 parameters. Using the light pen, numerical values can be chosen and given to any of the parameters of the program. One soon learns how to control the graphic possibilities of this new medium and realizes that it is a very powerful and versatile figure generator. When the camera is used, control of the computer program is by punched cards, not the light pen. The camera, using black and white motion picture film, is automatically operated by control signals generated by the computer program. At a later stage, I recopy, with an optical printer, the black and white images onto color film. Using an assortment of color filters and superimposers, I am able to produce the images which you will see in the remainder of this film. This is one kind of action that I have been exploring. Asymmetrical, not center-oriented, a fluid kind of motion that is not stuck in one place. This motion is multiplex, no static elements except when it comes to rest. It has a path in space which is approximately a trajectory. I call it a linear figure. The essential problem with this kind of motion must resemble the creative problem of melody writing. It is, perhaps in its purest form, the most highly concentrated case study of the essence of art itself, involving as it does balance, contrast, tension, and resolution, all brought into play with minimum expenditure. Perhaps if these actions were structured with still greater contrasts of motion and scale, and some as yet unknown qualities, they might be developed through variations that we could recognize and respond to directly and emotionally. Of course, even these actions on the screen might work better if there were music of some sort related to them. I think of sound as a partner to this kind of visual experience, but I do not want the graphics to play a role of the lesser subservient partner. Starting with recorded history, I suppose we have had as much experience creating melodies as creating poetry. But who has experienced the satisfaction of composing more than a fragment in this new audiovisual art? What is needed, therefore, is for someone to be able to add a few years' experience to perfect his skill at designing motion for the eye to perceive. You have been seeing a kind of motion which I would have you compare with melodic linear phenomena of music. The comparison might be carried a step farther by showing how we might relate and harmonize two or more actions that run simultaneously. Here is a simple and obvious and quite infallible kind of polygraphic relationship. Parallel action rotated into 4 quadrant positions. Now, from here on, I'm going to present a kind of spoken counterpoint. I'll interrupt myself to explain what is on the screen, but I have more to say in general about formal problems. For example, the op art directions have indicated what values can be found in the effects of color as an experience for its own sake. There are the same potentials here, but with the added factors of time and motion. Let me add a disclaimer to any systematic color aesthetic at this time. I am using color on the elemental level of a simple color code system at present. On the screen now are polygraphic relationships of related pairs derived from structural configurations of the computer program. The relationship is still simple, merely completing the other half of a basically circular figure. These more dynamic relationships begin to illustrate some of the potentials of the computer as a graphic variational instrument. Yet the obstinate part about these actions we are seeing is their subtlety, their ambiguity. They remind me of certain optical puzzles. You actually have to be sharp-eyed and have your wits about you to see these relationships I am describing. This becomes too much a kind of intellectual game. All this that you see here should impinge upon the emotions and feelings directly. It does not do that very well, but I think it can and will. Now, here the pairs show their mating relationship as they move in a depth of space. Music, of course, has its impact directly, and emotions are involved in composing music. The tiresome misconception that composers work in a heat of passion has given way to its opposite, that the short-haired modern composer is supposed to be all brain. I don't have to labor the point that music and music composing actually allow for a free and easy involvement of the emotions. But I must say, to get emotionally involved creatively at the computer is not easy. One considerable problem has to do with the matter of real time. Here, the orange figure moves in space while the yellow remains at a constant distance. These actions on the screen were not produced in real time. In fact, it takes 3 to 6 seconds to produce one image such as we see here, passing at the rate of 24 frames per second. One 20-second sequence requires about 30 minutes computer time. Then I must wait some 12 hours or more to see my film after it is processed. This is another dynamic relationship. The yellow and orange figures complete a closed figure, but the connecting lines are organized differently. Imagine how handicapped a pianist would be if his piano made not a sound as he played on it, and he had to wait some 12 hours before he could hear the music he had performed. The musician's reactions and his emotions and feelings are easily involved because all musical instruments to this day have operated in real time. But computers are evolving toward real-time operations with a material as complex as this, and I expect some of the hardships to ease. Now, these mated pairs advance and retreat in time opposed to each other. As difficult to combat as the old misconceptions about the romantic composers may be the ideas floating around that we may turn to art by computer as a labor-saving device. There is so much misunderstanding about the so-called electronic brain, which is supposed to do the work of 100 or 1,000 scientists. You can already expect to hear talk of the computer doing the work of many artists. There would be less nonsense in this if it were put the other way around. I would gladly share the task that lies ahead with many others who, I am sure, are abundantly cognizant of the problems. In fact, to me, it seems likely that problems such as I have tried to outline here will one day be collectively studied at many centers devoted to the computer arts. Now, in conclusion, I would like to present a brief analysis of the film Permutations, which is the most recent of several films which I have made as one of the many activities within my IBM research project. Permutations represents a first step toward developing a compositional language by which an art of graphics in motion might be structured in time. That is to say, with this film I have been able to realize, on a decidedly tentative and experimental level, a hierarchy of components of a structural system. At least I have been able to put the pieces of this system together in different ways to achieve different effects, as with a language. On the screen now, consider the generalized effect of these dots. Whether moving in orderly, deliberate paths or bouncing around in seemingly random fashion, they have a lively, dynamic quality, and they form collectively into figures at times in ways which I find I can arrange with much more graphic integrity than any of the other line figures of the first part of this talk. This dot pattern domain of the computer program might be compared with an alphabet. If so, at the next level of complexity, the dot patterns form into words, each word having a 200 frame or approximately an 8-second duration. The words in turn can be fitted contextually, one after another, into sentence structures, such as you see on the screen now. My use of a parallel to language is only partially descriptive. One is again moved to draw parallels with music, and the next term I would use is, of course, counterpoint, or more exactly, polyphony. But comparisons with either language or music are tenuous at best, For example, this simple succession of the same graphic figure or word over itself again and again is certainly not producing anything like the effect of musical canon and is without parallel in linguistics. In summary, I must comment that if this kind of computer art study looks like a lot of fun, which it is, let me add there is some agony in it too. A few years ago, a fairly serious survey lecture on the state of the computer art at Rand concluded with the lecturer's own aphorism: computers are getting smaller, faster, and cheaper year by year. My threefold agony is that computers are not small, fast, or cheap enough. Let me say here, my use of the word agony is really in the lofty Christian sense. I don't personally suffer, but I do for others in the sense that because, one, computers are not cheap, fewer people have an opportunity to use them as I do. Two, because computers are slow, people have to wait in line behind me while I do a camera run. And three, computers are too big to take home over the weekend to finish work when it gets behind schedule. Still, computers are becoming smaller, faster. Suppose my real agony is one of impatience. I expect to see one day an art of graphics as a regular daily part of television programming. I am impatient with the probability that to bring this about will require about as much invention, hard creative work, and digestion of many new techniques as will be required to bring about the home television-size computer.
Suscríbete a nuestro canal. Ayúdanos a crecer, y disfruta de todos nuestros contenidos.